Okay, guys, welcome back to the tutorial. We're still working on that good old attribution method. We're getting closer and closer to the Shapley value. Where are we now? Remember in our previous tutorial, we were starting with saying, hey, if I've got a set or if I've got a coalition of players, Facebook, Instagram, and YouTube, we know what they can do on their own, right? We know Facebook can win 7 points. We know Facebook and Instagram will also win 7 points. We know that Facebook and YouTube will win 15 points and so on. So we did this in our previous tutorial. In our previous tutorial, we took our series, we sorted the text string into the set, and I forgot to show this, but we then joined the sorted series and the original data together. And this time we grouped it by the ordered series and include the number of players. In other words, Facebook, Instagram originally had 23 people in the series, and Instagram, Facebook had 10 people in the series. But when I look at it as a set, Facebook and Instagram, that team combined earns 33. Okay, that gets us this data here. How many points does Facebook and Instagram or Instagram and Facebook earn? The total is 7. Cool. We're on to the next step. The next step is to try to calculate the different play orders that I could have for this coalition. For the coalition of Facebook, Instagram, and YouTube, I can have 6 different combinations. For the team, Facebook and YouTube, I can only have 2 different combinations or 2 different play orders. All right, how do we calculate all of the different play orders given a set? All right, here's where we left off. My data looks like this. I know the set. We're actually going to do the same thing that we did in the preceding code. It's going to look very similar. So let's go through it. We want to identify all of the possible. Right. Okay. Sorry, guys. Got a little confused there. Got myself flustered. Okay. We want to know all of the different ways we can combine Facebook, Instagram, and online display. And in order to do that, the first step is to figure out, okay, who are all of my players? So again, we're going to do the reverse of what we previously described. We're going to count the number of hyphens. We're going to join on the one-to-many table, and we're going to keep the first, second, and third player. Okay, we know that math. It's the same thing again. But what we're going to do differently now is now that I have one row per player in an ordered series, I now have to find the 6 different ways I can combine them. And so what we did here is we said, okay, do a self join between table A and table B. And what we're going to do is make sure that series A is equal to series B and the player A does not equal player B. I'm going to make a copy of this code and let's just run this as a small example. Um, we're going to learn how to do combinations here. So we're just going to do A and B. And I'm going to exclude all references to B, C, and E. And I have an error on row 13. Okay, so let's start with the easy stuff. Um, Here. The ordered series is Facebook and Instagram, and we know that there are two ways of combining this. We combine this as Facebook Instagram or Instagram Facebook. For something with 3 players, we know there's 6 ways we can combine this. Facebook, Instagram, online display, Facebook, online display, Instagram, Instagram, Facebook, online display, Instagram, online display, Facebook. Okay, in order to get player 3, I would have to join the table onto itself a third time, right? So I would have to do left join table series by player C, and then I would just have to extend my join criteria. So I would say, hey, let's call this table C. I want to make sure that A is equal to B. I want to make sure that A is also equal to C. And A dot player does not equal to C dot player because the player can't go twice. And B dot player does not equal C dot player. Okay. If you have too many channels, this very quickly gets cumbersome, but we're going to add in c.player as player 3. If I set this up correctly, 1, I shouldn't get any errors, but 2, I shouldn't see any cases, any examples of repetition. So here, Facebook, Instagram, online display, Facebook, online display, Instagram, Instagram. Here, these should be 6 permutations, right? And no repetition. Okay, this is okay to just kind of prove that it works, but in order to see the play order, I'm going to combine them. I'm going to coalesce them all into one column. So I'm doing if I know that I have 3 players, then I'm going to concatenate underscore white space, I think it stands for, and I'm going to use a hyphen as a separator, and I'm going to concatenate A, B, and C dot player. So Facebook, Instagram, da 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 da. Okay, now down here I'm getting nulls because these have 4 players and I haven't accommodated for the join criteria for player 4. Okay, so again, what are we doing? We're saying, hey, for this coalition, for this team, Facebook, Instagram, YouTube, what are the different orders that they could play their turn in? What are the different orders that they can contribute to the total score of 19? So we have to come up with these 6 combinations. And how did we do that? We said, well, first, identify all of the players and then combine them in all the possible ways where a player does not go twice. That's functionally what this complex join is doing for us. You'll notice here, hey, here's our friend, the at row variable. And what are we doing here? We are just incrementing the variable. Row is equal to row plus 1. And that I'm using that to call it the coalition number. So my series or my coalition is called Facebook Instagram. And then the coalition, I should call this play order, is the first and second. So here, the first and the second play order. I've got 2 players, and they're both responsible for 33 conversions, right? We said no matter the order, we would expect them to have the same number of conversions, the same performance. Okay, we're going to wrap up that tutorial. What did we learn? We learned how to calculate combinations.